Hello and welcome to Global Math Mentor. In this video, we are going to tackle some CIE Pure Mathematics 3 past paper questions on complex numbers, a topic that many students find tricky, but also really rewarding once it clicks. I'll solve each question in a clear step-by-step way so you can follow along easily. Make sure you pause the video and try each question yourself before watching the solution. It's the best way to learn. Let's jump right in and master a complex number together. So here goes the first one. This is from summer 22, question paper 3-1, and it's question 7 on that exam. Come on, if you want to try it, you can pause it and then come back and check my work. So let's go. The complex number u is defined by u equals to this expression, which is a fraction where a is a positive integer. Okay, you can see that a over there as well. First part, express u in terms of a in the form x plus iy, where x and y are real and exact. So for questions like these, the skill is to rationalize this expression. How do you rationalize? Let's find out. Iota divided by, this is going to be 1 plus 2i. So you multiply and divide by the conjugate of the denominator. All right. So what's the conjugate of the denominator? You can see that the denominator is 1 plus 2i. So its conjugate is 1 minus 2i. Now we multiply the numerators and denominators and then try to separate the real and the imaginary part. So it's going to be square root 2 minus 2 square root 2 iota minus a square root 2 iota and plus 2a square root 2 iota square. So divide the whole thing by, instead of just multiplying the denominators, I can use the identity a squared minus b squared. So know your algebra. And let me just simplify the denominator here. 1 minus 4 iota squared. So since iota is a square root negative 1, so iota square is minus 1. So this is going to be 5 because minus 4 times minus 1 is a plus 4, and then we add that and get a 5. So let's separate the real and the imaginary part to make it look like x plus iota y. So square root 2, remember this thing is going to be a negative 1 as well. So my answer will now look like minus 2a square root 2 and divide by 5 and plus, let's just bracket it down, and it's going to be minus 2 square root 2 minus a square root 2. You know what I'm doing? I'm factorizing the iota out to make it look like x plus iy. I mean, what else can we do? There is a positive integer, so maybe if you want to go, this is just optional. This can be your final answer for part A, but if you want to further factorize it, let's common the square root 2, and it's going to look like 1 minus 2a divide 5. And maybe you can write this thing as minus square root 2. And what will this look like? 2 plus a divide 5 and iota, right? I just did it extra. So nowhere does it say that you need to give your answer in factorized form. Yes, it does say that you need to give your answer in real and exact form. So what does it mean by exact? You will keep the square root 2's as they are and the fractions. Don't turn them into decimals. Let's look at part B now. It is now given that a is 3. Okay? So B part says express u in the form re iota theta, where r is greater than 0 and theta is within minus pi and pi, giving the exact values of r and theta. So what is this re iota theta? If you remember it, that's good. But if you have forgotten it, that is the exponential form of a complex number. And the one which was given in the question was the Cartesian form. So I'll share the link in the description. You can check that video out where I have explained it in detail how to convert between different forms of complex number. So I'll be needing my part A. So let's go. That's part A. And I need to substitute A3. So this will become root 2 minus 6 root 2 over a 5. And plus iota, this is going to be minus 2 root 2 and minus 3 root 2 divide a 5. So this will become minus 5 root 2 divide a 5. So the 5's cancel. So this is going to be minus root 2. And this is a negative 5 root 2 over a 5. So that will also become a negative root 2 iota, right? So that's my simplest form after substituting a to be 3. So what is the modulus? Modulus is the magnitude of this complex number. So negative root 2 squared plus a negative root 2 squared and square root it. This is going to be 2 plus 2, which is a 4, and the answer is going to be 2. Now I need to check the argument. Since this theta is the argument, r is the modulus, let me just write it so you can save it to mod, and theta is the argument. So check the quadrant. This is the third quadrant. So make an axis on an Argand diagram. This is real. This is imaginary. It's going to be here in the third quadrant. So negative root 2 and negative root 2. So the answer over here is going to be theta will be the tan inverse of a 1. So that's a pi over 4. But I need to give my answer in the... So look at this. Since theta is between negative pi and pi, I cannot go this way, though it is a correct answer, but according to the given domain, it will be incorrect. So I need to go clockwise. So when I go clockwise, my answer is going to be pi minus a pi over 4, which is a 3 pi over 4. But students, remember the clockwise angles are negative. So this is going to be a correct answer for the value of theta, and r is 2. Now I write my u in the exponential form. That's going to look like 2e a negative 3 pi over 4 iota. That's my final answer, right? Let's look at part 3 now. Part C, using your answer to part B, find the two square roots of u, giving your answer in the form r e iota theta, where r is positive, theta is within minus pi and pi, giving the exact values of r and theta. Well, there is a video where I have explained how to find the square roots, but in Cartesian way. How do you find square roots in polar, the Euler form or the exponential form? So there's a connection. So make sure you know this, that r e iota theta can also be written as r cos theta plus iota sine theta. So you got to be careful with these and don't use that method because it's just a 3-mark question. Cos and sine are circular functions, and you know that after each 2 pi, their angle value remains the same. So keep that idea in mind. Let me just bring the previous part's answer, and let's quickly learn how to find square roots in exponential forms. Square root it. So when I square root, the modulus becomes square root 2, and there are 2 possible square roots. So you can write this half and minus 3 pi over 4 and a plus 2k pi. Why am I putting a k pi? Because k, I'll put a 0 and then I'll put k equals to 1 and I'll get my 2 square roots. You'll find out how. So the first one is going to be square root 2. And you know k is 0 because there is no circular movement. It's just the first angle. E negative 3 pi over 8 iota. That's my first answer. And for the second one, it's going to be square root 2 e half of, this is going to be minus 3 pi over 4 plus a 2 pi, right? Iota. Let's simplify this. It's going to be 8 minus 3. That's a 5 pi over 8 iota. And that's my second answer. All right. So this one is from summer 22, question paper 3.3 and question 5 on that exam. The complex number 3 minus iota is denoted by u. So u is 3 minus iota. And a part, show on an Argand diagram with the region O, the points A, B, C representing the complex numbers u. So this is A. And what is B? B is the conjugate. U star is going to be 3 plus iota. And what's C? It's the difference of the conjugate and the complex numbers. So this is 3 plus iota, let me just write it, u star minus u. So that's going to be, okay, let's simplify this. It's going to be 3 plus iota minus 3, and it will change the sign. Plus iota, this cancels, so this is going to be 2 iota. So I need to put them on the Argand diagram and see, state the type of quadrilateral formed by the points O, A, B, C, where O is the origin, we know. Okay, this is real axis, this is imaginary axis, and let's put a 3 minus 1 first. 1, 2, 3, and minus 1. This is the point A, okay? And 3 plus 1. Well, you see, this is B. Complex number and its conjugate, they are reflections in the real axis, right? Or the x-axis, you can say. So this is 0, 2 over here. This is C, and this is O. Let me use a different color pen. So this is going to be CB, origin, that's OA. Well, I can see this is a parallelogram. Okay, you might be thinking like, is this a 3-mark question? I mean, if you want to like go one step forward, I don't think so. The mark scheme requires that, but the gradient of CB, if you check it, it's going to be, let's do it, because this is a 3 and a 1, and this is a 3 and a minus 1, and that's a 0, 2. So if you want to find the gradient, it's going to be a y2 minus y1 over x2 minus x1. So that's negative 1 over 3. And this one I can clearly see the gradient of OA is negative 1 over 3 as well. So opposite sides are equal and parallel, and these two I can check. This is a 2 and this distance is a 2 as well. So the quadrilateral formed is a parallelogram, right? That's A part. Part B, express u star over u in the form x plus I, y, where x and y are real. U we know from part A is 3 minus iota, and u star is going to be 3 plus iota. So let's divide complex numbers. How do you divide? It's the same process, rationalization. You multiply and divide by the conjugate of the actual complex number in the denominator. Let's simplify the numerator. That's going to be 9 plus 3 and 3. That's going to be 6i plus iota square. And the denominator is going to be 9 minus I square. So that's 8 plus 6 iota. And divided by, that's a 10, right? So let's write it. 8 over 10 is going to be 4 over a 5 plus 3 over a 5 iota. So that's our answer to part B. Part C, by considering the argument of u star over u, or otherwise prove that tan inverse 3 over 4 is 2 tan inverse 1 over 3. It's just a 2-mark question. I need my answer to part B, which is this one. And that's a u star over u. Okay. So I need to consider the argument of u star. They are giving me a hint I need to consider. Well, that's the magic of argument. It just works like logarithms, right? Well, don't get confused. It has nothing to do. It's just a coincidence. So if you multiply and find argument, it's going to be the sum of the individual argument. And similarly, if you apply argument to a fraction, it's going to be the difference argument. So if you want to find out how this is and you want the explanation, write a comment. So maybe I'll give a quick video later on and I'll explain why this happens. Okay, so if I use this idea, so let's get the argument of this one. This is the first quadrant. I'm not making the diagram, but I know 3/5 divided 4/5 is going to be a 3 over 4. So, well, that's the left-hand side. Let's put it here. Tan inverse 3 over 4. Now, what is u? U is 3 minus iota. So it's here somewhere. And its conjugate is here somewhere, 3, 1. And that's a 3 and a minus 1. So this is a tan inverse, a 1 over 3. And this one is a clockwise tan inverse 1 over 3. So that's going to be a negative. You remember that clockwise angles are negative. So if I substitute these values over here, it's going to be tan inverse 1 over 3. A minus minus is a plus tan inverse, a 1 over 3. So this will end up 2 tan inverse, a 1 over 3. And that is the result that I was trying to prove, right? So remember what I just told you. Magical properties, arguments, they sort of work like logarithms. Well, hats off, guys. If you are still here, it means you are serious about study and you're working really hard. I gotta give you hats off. So this is from winter 2008, question paper 3 and question 10 on that exam. I do not think there were variants back in the days, but let's take a look at this older exam question. So the complex number W is given by W equals to W is a negative 1/2 plus root 3 over 2 iota. You can write iota anywhere, like in the first place or the last place. Find the modulus and argument of W. So let's get the modulus. It's going to be a negative 1/2 square plus a root 3 over 2 square and square root, right? 1 over 4 plus a 3 over 4. That's a square root 1, so that's just a 1. Well, the modulus is 1. Let's get the argument of W. This is the second quadrant here somewhere. So this distance is a 1/2. This distance is a root 3 over 2. So imaginary, real. You can do it quickly, but for explanation's sake, I always make a diagram just to make you people understand better. So I need this angle, this theta. This is going to be tan inverse of, what's a root 3 over 2 divided half? That's just a root 3. So from my special triangle, I know this angle is a pi over 3. But remember, guys, I need to check with the positive real axis. So pi minus a pi over 3 is going to be a 2 pi over 3. And that's the final answer of the argument. And this is the modulus. Let's look at the next part. Part 2, the complex number z has modulus r, which is an unknown alphabet, and argument theta. Where theta is within pi by 3 to pi by 3, state the modulus and argument of wz and the modulus and argument of z over w. And it's just state. So you understand, like by state, they mean that this is something which you need to memorize, you need to learn. So let me just quickly give you an idea. I was talking about this earlier in the previous question as well. So let me just give you the form. If you have two complex number, let's say z1, r1 cos theta 1 plus iota sine theta 1. I mean, in order to understand this question, you need to get yourself familiar with these ideas. Z2 is going to be R2 cos theta 2 plus iota sine theta 2. Now, you do not need to prove these, but getting to know them is very important. And maybe those students who are taking further maths, 9231, can dive deep into it and go ahead, prove these things. So the results look like this. When you multiply these two in polar form, their moduli multiply like R1 and R2. And when you multiply these two expression, cos theta 1 plus iota sine theta 1 and cos theta 2 plus iota sine theta 2, you will end up using the compound angle formulas, a result like this, plus iota sine theta 1 and plus theta 2. Okay, I know it looks scary, but I'll explain you in a bit, like what does this mean? When you divide them, this is even a harder one to prove. Again, the normal 9709 A-level mathematics students, uh, there's no compulsion of proving these, just knowing them is enough. So this will end up the modula, it will be the fraction. The modula will be divided like this, R1 and R2. And the arguments will be this by, the compound angle formulas like cos theta 1 plus theta 2 is a compound formula. It's given in the formula booklet as well, iota. This will be sine theta 1 minus theta 2. So now what's the catch from here? Let me just use a different pen to show you. So when you look at the argument of Z1 and Z2, that is the sum of the arguments of individual arguments of Z1 and Z2. So you can say this is argument of Z1 plus argument of Z2. So that's the property which I was talking about earlier. And look, the modulus of Z1, Z2 is gonna be the product of the individual moduli, which is like Z1's modulus and Z2's modulus. So I know it's a little bit harder to understand, but once you take out some time, note it down, then their applications are really significant, and you can just, because why otherwise they're saying state. That's the reason. So I can write the other important result for you too. Z1 over Z2. If you want to find the modulus of this thing, is going to be the uh, fraction of individual moduli like R1 and R2. And the argument of Z1 over Z2, like I used earlier, just rewind and look at the previous question. I used the same idea, is going to be the difference of the individual arguments of Z1 and Z2. So this is really important, guys, for you to know. So just make sure you copy it down and then I'll erase it and I'll go towards the question. Okay. So let's just erase it quickly. Okay. Uh, come on. Let's go. Okay. So now it's over. Let's come back to the question. So I know there is some complex number z. So the modulus of z is just r, and the argument of z is theta. And from my previous part, we know already that the modulus of w was 1, and the argument of w was a 2 pi over 3. I just proved it in the previous part. So let's use them to get the argument of, modulus and argument. So first, let's get with wz. What will be the modulus? We have the individual moduli, we can just multiply them. So r times 1 is just going to be r. So this is one answer. An argument of wz, I'm just stating it. It's going to be the sum of the arguments of z and w. So this is going to be theta plus a 2 pi over a 3, right? Let's just box it. Now, the second thing is z over w. What will be the modulus of this thing? So this will be the modulus of z divide the modulus of w, which is r divide 1, and that's just going to be r. And the argument of z over w is going to be the difference of argument of z, theta, minus a 2 pi over a 3. So these are my answers to part 2. The reason it got so lengthy, this explanation, is that I wanted you to understand those special properties of arguments and moduli, right? Let's look at part 3 now. Part 3, hence explain why in an Argand diagram, the points representing z, wz, and z over w are the vertices of an equilateral triangle. So we know that length of each of them is r, right? Z, w, z's modulus is r as well. And z over w's modulus is r as well. But this argument of z is a theta, and this argument we calculated already. This was because it's a product, it's going to be the sum of the argument of w and theta, and this one is argument of z is going to be theta minus a 2 pi by 3. So now I'll try to justify that these are vertices of a right angle triangle. First, I need to sketch them, and I know that z is somewhere within a negative pi by 3 and a pi by 3. So it can be either here somewhere or here somewhere, but I'm going to be taking it in the first quadrant. Let's take it in the first quadrant and see what happens. So it has to be below 60 and within like 60 and minus 60. So I'm thinking about it in my head. Let's say it's a complex number having a modulus of r, z, and its angle is, think of any acute angle in your head, like 40. But I'll call it theta, but in my head, I'm thinking about it like a 40-degree angle. This makes things easier for sketching and stuff, right? Okay, so now what about WZ? If you add a 2 pi by 3. 2 pi by 3 is 120. So think about it, 120 plus the angle that was you were thinking in your head, like I am thinking 40. Still, it's 160. So it will end up somewhere here, like let's say here. Okay. So this is a WZ, right? And this angle in the middle is going to be a 2 pi over a 3. Okay. Now, if you subtract 120 from this acute angle, 40 minus 120 is going to be a minus 80. So you get my point, students. I'm thinking about it like taking some specific value and sketching it that way. So this angle over here is going to be a theta minus a 2 pi by 3. But remember, guys, this is a negative angle since it's a clockwise one, right? So if this is a 2 pi by 3, now I need to check what happens if I add theta plus a negative, or let me just write it like this, square bracket, negative theta minus a 2 pi over a 3. I'm trying to prove it that this will end up just 120 again. So this is a 2 pi by 3. So this angle in the middle is again a 2 pi by 3. And we know that from the circular angles, this is going to be a 2 pi over 3 as well. If I connect these, uh, I think I've got it. So if I connect this, these angles are going to be a pi by 6. Each of them a pi by 6, right? You know why? Because pi minus a 2 pi by 3, this is an isosceles triangle, so this becomes a pi by 3, but you need to divide the result by 2. So each of the angle become a pi by 6. If you're not good with calculations on radians, first suggestion is work on radians. If not, you can think about this as 120. So 180 minus 120 is a 60. If you half it, each of the corner angle become 30. Now from each of these triangles are congruent, right? So this is a pi by 6, a pi by 6. I'm doing some extra effort, though it's just a 2-mark question. But you know, these distinction sort questions, these harder questions are sometimes with a lesser mark. I mean, that's a plus as well. Even if you don't, even if you lose marks on these questions, it's just a 2 mark. So that's a good shout out. Okay. So each of my corner angle is now pi by 3, pi by 3, pi by 3. So that's an equilateral triangle. Hence, by this diagram, triangle is equilateral, right? Oh boy, that was really a hard one. I'm going to star this one. But if you have focused on this part, you can use these ideas elsewhere for such harder questions, right? So this is part 4 of the same question. In an Argand diagram, the vertices of an equilateral triangle lie on a circle with center at the origin. One of the vertices represent the complex number 4 plus 2 iota. So 4 plus 2 iota is one of the vertices. Find the complex number represented by the other two vertices. Give your answer in the form x plus iy, where x and y are real and exact. Now, this is something worth noting. If in a question you are required to prove something, and there is a next part. So in these A-level questions, you can use the previous part's idea to get your answer in the next one. So just like there was something about equilateral triangle in the previous part, like z, some random complex number multiplied with w and z divide w gives you an equilateral triangle. So now I can take this as z, and my w is a minus 1 over 2 plus a root 3 over 2 iota. So I can now multiply and get these two, and these will be my required answers. But my answer needs to be exact. So let's go. ZW. Let's just go over these calculations. 4 plus 2 iota and times a minus half plus a root 3 over 2 iota. This is going to be minus 2 plus 2 root 3i minus iota and plus root 3 iota square. So iota square is a minus 1. So this is going to be minus 2 minus root 3. That's the real part, plus 2 root 3 minus 1. And that's the imaginary part. Let's box this one. This is one of the answers. Now z over w. So I need to rationalize this. 4 plus 2 iota divided by minus half plus the root 3 over 2 I. So how do you rationalize? You multiply and divide by the conjugate. So these are exam questions. So I've done something like this before, but I just want to solve each of them fully, whichever we have picked for solutions. So let's simplify the numerator. Minus 2 root 3 iota and minus iota and minus root 3 iota square. Divide the whole thing by a negative 1/2 square minus a root 3 over 2 iota square. I just use the difference of two square identity. 1 over 4 minus a 3 over 4 I square, which is going to be, well, that's a 4 over 4, 1, right? So now I'm left with minus 2 plus root 3. That's the real part. And I mean, I can factorize the negative out. No compulsion. Plus 1, and that's iota. So these are my answers for this fourth part. So this is from Summer 18, question paper 3-3, and question 9 on that exam. Let's take a look at this one. A part, find the complex number z satisfying the equation this, where z steric denotes the complex conjugate of z. So how do we solve these kind of equations? 3z minus iota z steric and equals to 1 plus 5 iota, right? So, I mean, I do not know what is z, so let's suppose it's something. So let z be a plus iota b. Then what will be z star or steric? It's going to be a minus iota b, which is the conjugate. So I'm going to substitute those here, a plus ib and minus iota times a minus ib. Let's simplify the left-hand side first. So, I mean, you can write the whole expression, but I'm just simplifying the left side first. So it's going to be 3a plus 3bi and minus ai and plus b iota square. So the real part is going to be 3a minus b, and the imaginary part is going to be 3b minus a I. So we know that this complex number is this left-hand side is equal to the right-hand side. So now you can equate the real and the imaginary part. Let me just write it, equating real and imaginary parts, right? So that will give me 3a minus b equals to 1. And the other one is, let's write it like this, minus a plus 3b equals to 5. Now I can just solve these equations to get the value of z. So if I multiply the lower equation with 3, negative 3a plus 9b equals to 15, subtract these, it's going to be 8b equals to 16. So b is a 2. Okay. And let's sub it back in one of the equations. 3a minus 2 equals to 1. So 3a equals to 3. A equals to 1. These are my a and b. So z is 1 plus 2 iota. That's the final answer. So this is part B. On a sketch of an Argand diagram, shade the region whose point represent complex numbers z which satisfy both inequalities. So one of them is z mod equals less than equal to 3. And the other one is imaginary of z is greater than equal to 2, where imaginary z denote the imaginary part of z. Calculate the greatest value of argument of z for the points in the region. Give your answer in radians correct to 2 decimal place. So as discussed in my previous video, I'll share the link, another link in the description that is all about these loci. So let's take a look at this first one. So if you consider this just an equation, z minus 0, 0 equals to 3. That's a circle and center is origin. So I'm going to be sketching an Argand diagram, like real part, imaginary part. So this is center origin. So it's going to look like this, right? So let me just use a little bit technology to make it in the center. But I discussed earlier in my locus video that take your compass with you, so it will be better to construct like a better circle. All right. So this is a 3, this is a 3, this is a -3, and this is a -3. That's the first bit. And now what exactly is imaginary of z equals to 2? So this is a horizontal line passing through a 2, right? So this is 2, and this line is passing through here. Now I need to shade the region. So less than equal to 3 means it's inside the circle, and greater than equal to 2 means it's above this region. So let me just shade it this way. This is the required shaded region. All right. So you can see it's above the line y equals to 2, which is obviously imaginary z equals to 2. Let me just write mz equals to 2, right? Okay, now that's not over. I need to calculate the greatest value of argument of z. So argument of z is the angle from the origin, right? So you can see that I can have different angles like here, but what is the biggest possible angle? So this is the biggest angle which is possible. So let's take a look at this, how we can calculate this angle. So, all right, so that's this one is a 2. And we know that the radius of the circle is 3. So this one will be 3, and this is a 90. So I need this angle, basically, this whole thing from here to here. So the right part, which I can see right now, is a pi over 2, which is a 90. All I need is this, just the angle in this right triangle. If this is 2, this is 3. Let's get this angle. And they're saying argument z for the points of the region, giving your answer in radians correct to 2 decimal places. So let's get this angle first. So this is going to be cosine inverse of a 2 divide 3. So I can use Desmos for this one. This looks easier. You obviously will use your normal scientific calculators for this one. So let's do cosine inverse a 2 over a 3. So that's a 0.84106, but I need to add a pi uh, over 2 as well, right? And plus, let me just, can I copy this answer? Yeah, I can copy this, Control C, and let's put it over here. So this is going to be 2.41. So if I needed 2 decimal places, the answer is going to be 2.41. Let me just re-explain it. This whole thing is the required angle. So this part of the diagram is a 90, which is a pi by 2, and rest is just whatever I've calculated in my calculator, and that's my answer. So here's another one from Winter 13, question paper 3, question 9. Without using a calculator, use the formula for the solution of quadratic equation to solve this equation, giving your answer in the form a plus ib. So we can see it's a quadratic equation. A is a 2 minus iota, b is a positive 2, and c is just 2 plus I. So I need to use the formula for the quadratic equation. So this will be minus b plus minus, let's do this one, b squared minus 4a and c, and divide the whole thing by a 2a, 2 minus I. Well, I can do this simplification of the inside this third here, let's say. 4 minus 4, and this is going to be, oh, this is again a difference of 2 square identity. So a squared minus b squared, right? It's going to be 4 minus 4 times 5, which is a 4 minus 20. This is going to be negative 16, right? So if I have, okay, let me just show you what happens to this negative 16 inside. I mean, if this were a real number system, this was not applicable, but since it's complex numbers, imaginary numbers, this is going to be 4 iota. You can think it this way, that square root negative 16 can be written as square root 16 times the square root negative 1. Square root 16 is a 4, and square root negative 1 is iota. Divide the whole thing with 2 and 2 minus iota. You can factorize the 2 and cancel, and -1 plus -2 iota divided by 2 minus iota. So I factored out the 2 and cancelled. Now one of the possible solution is going to be -1 plus 2i divide 2 minus iota. Uh, and the other one is going to be -1 minus 2 iota divide 2 minus iota. So these are my required answers, but you can see that they are not in the form which is required. So I need to rationalize each of the roots again to get my answer. So let's do it. 1 plus 2 iota divide 2 minus I times the 2 plus I divided 2 plus I. And this is going to be -2 minus I plus 4i plus 2 iota square. Divide the whole thing by 4 minus iota squared. So I will be getting -4 plus 3 iota divide 5. So it's going to be -4 over 5 plus 3 over 5i. That is one possible answer. And the other one, we need to go again. It's just a 5-mark problem, but they want you to do it without the calculator. So that's the thing. They are interested in observing each stage of your work. -2 minus iota, -4 iota, and -2 iota square. Divide 4 minus iota square, which is going to be, oh, this cancels now because it's going to be +2 and -2. So -5i divide 5. I'm getting a minus iota. That is another root. Part B, the complex number W is defined by W equals to 2e pi over 4 iota. In an Argand diagram, the points A, B, and C represent the complex numbers W, W cube, and W steric, which is the conjugate, respectively. Yeah, they're saying it's the conjugate. Draw the Argand diagram showing the points A, B, C, and calculate the area of triangle ABC. Okay, so how do you get W cube? It's going to be 2e pi over 4 iota and cube. So this is going to be 8e 3 pi over 4 iota, right? So I'm using indices, and W steric, which is the conjugate. So you need to remember that conjugate is just the reflection. So its argument is going to be minus pi over 4. It has the same magnitude, but it's a reflection of the W conjugate. So let's sketch it. And they are saying calculate the area of the triangle represented by these. So this is real part and this is imaginary part. Okay, so how do you sketch a polar form? Now remember that when you look at this Euler form, which is r e iota theta, theta is the argument angle and r is the length of this complex number. So let's say if this is 2 and a pi over 4 here somewhere, I'm saying this is w, its angle is pi over 4, and this is a 2. And its conjugate, let's just make a reflection. And this is a pi over 4 as well, obviously in the clockwise direction. And this is W steric. Now look at this W cube. Its argument is a 3 pi over 4, which is a 45 in the second quadrant. And its length is 8. So it's a bigger one. Like if this is 2, this is 2, then this is a 3. You get it how I am sketching these polar forms, these exponential forms. Just use r as the length of the vector because it's like a vector on an Argand diagram, Argand plane. So this is a triangle and this length is, oh, that's a 8. Sorry, my bad. That's a 8. So the base of the triangle becomes 10. The height becomes, since this is a pi over 4, that becomes a 90 times the 2 and 1/2. If you simplify this, it's going to be 10 units square. That's the area. Okay, so here we are. This is from Winter 12, question paper 3, and question 10 on that exam. Before we start, I really want to appreciate you people. If you are still here, that's awesome. Wonderful. Keep it up. Keep practicing. This is going to be a whole hour of complex number. So part A, without using calculator, solve the equation this. So we're not allowed to use the calculator. And you might be thinking that we have the calculator. What possibly can go wrong if I use a calculator? Well, the examiners are pretty good at it. They know how to test your working. They want to see each stage of your work, your manual work, right? So what can be done about this? It's just a 3-mark question. Let's expand the right-hand side and see what do we get. It's going to be 4 minus 8i and plus 4 iota square. So this cancels with this, so I'm left with a negative 8 iota. So now divide both sides with iota and you're just left with this. Now you cannot square root a real number, but this, remember, is a complex number, so I can definitely square root it. So w is going to be a plus minus square root of 8 iota. So you can give your both roots as, let's say, negative 8i, square root I, and positive square root 8i. Or you can maybe write the simplest form like this, and 2 square root 2i. That's part A. So this is part B. And first part of it, sketch an Argand diagram showing the region R consisting of the points representing the complex number Z, where Z is this thing. Well, by now, I believe you know that this is a circle. Factorize the negative, make the right form. So this is going to be 4 plus 4 iota and equals to 2. For sketching sake, I can just use this thing. Minus a 4, 4. That's the center of the circle and radius is 2. So let's make an Argand diagram like this. So its center is in the first quadrant. It will be, let's say if this is a 4 and this is a 4 as well. It's going to be here. And the radius is just a double, which I need to bring it to the center. So you can use compass, remember? So yeah, this is what this will look like. So center is 4 and 4, and the radius is 2. Well, you can give the radius if you want to. Maybe write it anyway. You want to write it. Let's say if this is 2. Okay, so that's M and that's RE, right? So this is part 2. For the complex numbers represented by the points in the region R, it is given that Z mod is within P and Q and arg Z is within alpha and beta. So as mentioned earlier, you can see that this Z mod, you can write it somewhere, is the distance from the origin, like how far something is from the origin, because no reference point is given, so origin will be taken as a reference point. An argument of Z, it's a half line, so no fixed point is given, so it will be the angle from the origin. So remember, this is distance from origin, this is angle from origin. You can take notes on that. Find the values of P, Q, alpha, and beta, giving your answer correct to 3 significant figure. So I need my sketch from part B1. That's the sketch. Let's get it, and I'm going to be showing you what's going on in this diagram. So let me just use a different color pen. So distance from the origin. And remember, this is often students ask why it passes through the center. So remember, this locus is circle, and circle pivot, the reference point is the center. It's the set of all the points which are equidistant from the center. So every distance that you measure passes through the center. So origin is here somewhere, and I need to find that's going to be the max distance. So that will be the Q, and this is going to be the min distance from this locus. So that's going to be the P. So how do we get it? Let's complete this triangle. So this is a 4 and that's a 4. So let's apply Pythagoras theorem. So 16 plus 16 root, that's going to be a 32 root. So distance from the center to origin is 32. So this is going to be, so P is just a square root 32 minus a 2, and Q is going to be a square root 32 plus a 2, since you know that the radius is 2. I hope you understand. So let's quickly check this value because I need to give my answer correct to 3 significant figure. Square root 32 minus a 2. That's a 3.656. So 3.66. It's going to be 3.66. And let's get the other values. I can just change this into a plus sign. 7.656. It's going to be a 7.66. So these are my P and Q. Now there is another thing which is required. It's a 6-mark question. I need angle from the origin and the maximum possibility of that angle and the minimum possibility of that angle. So let me just make angle like tangent. So this is going to be the maximum angle. And this one is going to be the minimum angle. So make sure you take notes on that because these questions become harder if you don't understand how to do it. So this point over here, we know from the GCSE math that tangent and radius are perpendicular. So this forms a kite like this. You can check out that locus video, the other one, which I will share the link in the description. I have shared something like this there as well, but this one is really like, I mean, things can't get difficult than this. This is like a way advanced question on loci. Okay, how do we get these angles? You can use these right triangles. So if this is a 2 and we know that this is a square root 32, can we get this angle? Let's get this angle. So I've got a triangle like this. Let me just make it. The height is 2, the hypotenuse is square root 32. How to get this angle? So I can use SOHCAHTOA. So let's do function sine inverse, right, over 2 divide a square root 32. So this is a 0.361, 0.361. And this will be a 0.361 as well. Both of them are equal. This is a theta as well. So what is this angle over here? Oh, that's going to be a pi over 4. So make sure you pause the video and observe this. Let me just highlight it. If this is the case, you can see this is a triangle. So its height and base are both 4 and 4. So the angle at the center which it make is going to be a pi over 4. So one of the answer, I mean, beta is the maximum angle. It's going to be theta plus a pi over 4. And alpha is going to be pi over 4 minus a theta. So let's get these values and I can get my answers. So what is theta? This is theta. Let me just copy it. So Control C. I'm sorry, I'm not using a scientific calculator, but Desmos instead. So plus, let's put a pi divide a 4. So this is one of the possibility, 1.146. So it's going to be 1 point. Oh, my bad. I'm forgetting these values. 1.15. Okay, that's the 3 significant answer. And let's get the value of alpha now. So I'm going to be using, oh, let's just type it again. So pi divide 4 minus the same answer. I can copy it. That's the good thing. Uh, okay, so that's a 0.424. So this is a 0.424. Why am I giving 3 significant answer? It's asking for it 3 significant answers. And these are my values for P, Q, alpha, and beta. So this is going to be the last question on this video, and this is from Summer 14, question paper 3, 2, and question 7 on that exam. Sometime complex number questions can mix up with polynomial questions. You'll figure out how. There is a whole video. I'll share the link in the description where I have taught how to solve equation with complex roots. So they are saying it is given that -1 plus root 5 iota is a root of the equation. This z cube plus 2z plus a equals to 0. You can see it's a cubic equation. Showing your working, find the value of a and write down the other complex root of the equation. So we need the value of a and the other complex root. To find the value of a, I can just use the idea of polynomial. If this is a root and if I can substitute it back in the equation, my answer is going to be 0, which is part of the factor theorem. So let's do the z cube first. How do you do the z cube? I mean, you can apply binomial expansion, but let's do the z squared and then I can multiply this again with z to get z cube. You'll find out how. So -1 plus a root 5i and -1 plus a root 5i. I'm expanding this double bracket. 1 minus 2 root 5i and plus 5 iota squared, which is going to be a -5 minus 4 minus 2 root 5i. So now I find z cube, which is going to be -4 minus 2 root 5 iota and times again z. So you know what I'm doing? I'm multiplying the z squared with a z to get z cube. 4 minus 4 root 5 iota plus 2 root 5 iota. And this is going to be a -10 iota square, which is going to be a +10. So 14 minus 2 root 5 iota. Let's pick this value and plug it over here. So 14 minus 2 root 5 iota and plus 2 times the z, which is going to be just the same, minus 1 plus root 5 iota, and plus a equals to 0. Let's see, what do we get? 14 minus 2 root 5I minus 2 plus 2 root 5 iota plus a equals to 0. So you see the imaginary components, they just cancel each other out. So 12 plus a equals to 0. So a is going to be a negative 12. In order to write down, look, it says write down. So in that video, which I will share the link in the description, you'll find out that if the coefficients of an equation are all real, roots exist in complex conjugate pairs. So if one of the root is this one, the other is definitely going to be the conjugate of this. So please make sure you watch that video as well as you're learning, as you're improving. So this is very crucial. They ask you to write down the equation. I mean, if one of the coefficients would have been imaginary in this equation, roots would not have been in complex conjugate pairs. So here is part B. The complex number W has modulus 1 and argument 2 theta. Show that this identity W minus 1 over W plus 1 is iota tan theta. And it has nothing to do with part A. So sometimes you do get questions like these where the A part and the B part are entirely different. They have no link with each other. So W, I can write W as its modulus is 1 and the argument is cos 2 theta. So cos 2 theta plus iota sine 2 theta. So I have written a polar form for this complex number. This can be written as E iota 2 theta as well, like the exponential form, okay? So it's just a 4-mark question. Let's see how does it go. I have a feeling that it will be a lengthy one. So cos 2 theta and plus iota sine 2 theta and a minus 1 and divide the whole thing with cos 2 theta. Oh boy, this is going to be a huge one. Let's see. So it's good that I picked this one for the last question. Okay, let's separate the real part, which is without I, and the imaginary part, which is sine 2 theta. So you got to be careful with these double angle identities. I can see this double angle since the argument was a 2 theta. So this lesson is, I mean, for those who are really good at trigonometry can really excel at this lesson, but others can definitely improve by going back and practicing it all over again. So I need to rationalize this expression, and let's see, what do I get? I will get a cos 2 theta minus 1, and there will be a minus sign in the middle this time, sine 2 theta. Let's see if I can manage it within this space. Okay, and divide by the same thing, cos 2 theta minus 1. Oh, it's going to be the denominator's conjugate. Oh, sorry, my bad. So plus 1 and minus iota sine 2 theta, right? Here we go. So let's do some multiplication now. So when this times with this thing, you will get a minus b, a plus b. So this is going to be a cos squared 2 theta minus a 1. Okay. And minus, this is going to be a sine 2 theta, cos 2 theta minus sine 2 theta. And this will be the imaginary part. And this, I have multiplied this thing. Make sure you are with me and pause it if you want to, come back to that point. So plus, this is going to be sine 2 theta, cos 2 theta, and plus sine 2 theta. Oh, something is coming to my mind. I would have gone with the Euler form. Oh, but you'll be needing the Euler's identity to prove it that way. So do comment. And if you want to learn the Euler's identity, I'll definitely make a quick video, like a short, to explain you what's the Euler's identity. I think this question would have been way easier with that. But you can see that this was not part of the main A-level course, the Euler identity, but this question would have been easier with the exponential form. Okay, so the last, okay, let me just get a grip on it. So where was I? So it's going to be minus iota squared sine. Oh, that's going to be plus sine squared 2 theta. So stop here and we can think about it like if we can cancel something out. So the denominator is going to be cos 2 theta plus 1 whole squared and minus iota square sine squared theta. So that's going to be plus So sine squared 2 theta. So students, if you find this a bit quick, you can pause it and see that I'm pretty sure I'm doing it all right. So okay, so these kind of things take practice. I know that this and this will cancel each other. Why? Because the sine squared plus cos squared is a Pythagorean identity, the unit circle identity, that's a 1, and minus 1 becomes a 0. So the numerator now becomes, so when you expand the bracket, this will cancel each other out as well. So minus minus is a plus, you get a sine 2 theta positive and another sine 2 theta positive. So the numerator will now look like 2 sine 2 theta, and there is an iota as well. Let's take the denominator and see it's going to be a cos squared 2 theta. I'm trying my best to compress this result. Plus 1 and plus a sine squared 2 theta. Okay, that's a 1 plus 1. That's a 2 plus a 2 cos 2 theta. I think I've got it. You might be thinking that my result is a single angle, which is iota tan theta. Let's break this down and check your formula booklets. There are some results like these. So this is going to be a 2 sine theta cos theta, which is a double angle formula for the sine. Iota is there. And the denominator becomes 2. Common it 1 plus cos 2 theta. Or cos 2 theta, I can use 2 cos theta and minus 1. Okay. 2 cos squared theta minus a 1. That's a double angle formula for cos 2 theta. Let's get rid of these 2's. So now the 1's cancel each other as well. So I'm left with 2 sine theta cos theta and divide by a 2 cos squared theta. Well, students, there we go. It's proved. This cancels. So I'm left with a sine theta divide a cos theta. And there is a I as well. So this is going to be iota tan theta, right? So that's it for today, students. And I hope so. This was like a pretty huge video, but the purpose for making this was that I want you people to sit and even you can pause and save it for, you can watch it later if you get tired somewhere. Keep practicing. These questions are not easy, but once you start practicing, they will really make sense to you. All right. This is Global Math Mentor over and out.